Thank you for waiting. We'd like to open next session. Professor Tanaka is working for Kyushu Institute of Technology, and he's the associate professor of the information engineering. In regards to the research of the moving mobile robot, he's engaged in the education and research and development of embedded system. He was in charge of a lecture of the software engineering of the object-oriented language, but he had an idea to use Ruby as an development language for the embedded system. And Professor Higashi has been engaged many years for the embedded system for web and web application development. And together with the Shimane R&D Center, he's now engaged as the special lecturer. And together with Professor Tanaka, he is engaged in the development of the mruby/C. Today, the theme of the lecture is the small-sized IoT device development language, mruby/C. I am Tanaka from Kyushu Institute of Technology. We're going to divide this 30 minutes half and half so that we can share our time between us. And we are going to talk about mruby/C. And before that, I'm going to explain just briefly about mruby. This is my self-introduction. I am Kazuaki Tanaka. I've been teaching and researching at Kyushu Institute of Technology, mainly in charge of the programming and IT subjects. And Ruby, I don't think I need to explain here. So I have been using Ruby for many years. The execution of Ruby is called interpreter method. Of course, we use the VM. They use the VM internally. However, this is the interpreter method. That's the characteristic of this language. And garbage collection is one feature of this program. So the developer or user do not have to worry about the memory or releasing memory. This makes Ruby very easy to use for anybody. And here's the embedded system. This is my target area for my study. And embedded systems are in a lot of machines or equipment. Because they are inside of the machines, it's not visible from outside. However, it's been used in many different machines, such as automotive or industrial equipment, or mobile phones, or small wearable tablet or terminals. However, there are a couple of issues. Because this is so small, CPU or memories or time, how we can speedy process and execute, or the electric power. These are the issues we have, and we need to consider during development. And at the same time, these embedded systems are for operation of the machines. So we need the knowledge of both software and hardware in order to solve the issues for these embedded systems. This is the survey result of the government. The cost of the software is very high. The software development compared to the simple software, the hardware has to be also considered. So development cost for this embedded software will be high. The blue is the software, and the remainder is the hardware. And also system development environment or maintenance, including all those, maybe it's half and half. Looking at this situation, how we can easily develop the cost or efficiently develop the cost will be directly related to the cost of the product. So because of such a situation, I wanted to use Ruby in embedded system because it's easy to develop as a software. So why not use for the embedded system? This was my simple idea I had. But somebody should have already considered if it's so easy. And we need to look at what was the difficulty before. The interpreter method and dynamic execution, like I talked about GC, these are all related. In embedded system, the execution time has to use a lot of resource, meaning CPU. So the hardware cost has to be very expensive. That's why it's very difficult to use. And dynamic executions, GC will be conducted. And once GC occurs, we cannot secure the real-time operabilities. If there is a limitation for the time, this will be very difficult to achieve. That's why Ruby was very hard to use for embedded system. So we thought mruby. We have developed mruby, which is a lighter version of the Ruby. The memory of the execution will be minimized, and the real-time feature has to be achieved. These are two issues that we wanted to achieve. And also the syntax, they have to use the same syntax as Ruby. And also other system, we need to control the hardware, and hardware control driver is written in C language. So it has to have a like affinity with the C language. How we can read easily from C or how we can write to the C. This has to be secured quite easily, otherwise it's very difficult to use in embedded system. This is the history of the mruby development. As early as 2010, it's already started, and 2012 it became already open source. This is the functionality of mruby. When Ruby program is there, it will be converted to binary code as bytecode. This will take some memory. However, in the PC, we don't have to worry about this because we can do this all in our PC. And then this will be executed in the target machine. This memory can be minimized. Now, the main topic, IoT, mruby. IoT is part of embedded system. Of course, this uses the sensor, or this will be operated in some network. So it uses sensor as a hardware, and it processes data in software. Then the data will be transmitted to the network. So in IoT, like data will be processed and the data will be transmitted in cloud, which is out of scope of today as talk. So I'm going to talk about the first part. When we try to do this, we will face the same questions that we had before. It has to be smaller and it has to have a fewer cost. The condition will be even tougher compared to the previous ones. Like maybe the 1,000 or millions of the sensors has to be installed, and we need to make it very small. And cost and electricity, how we can supply the power, battery, cell, or security has to be considered as well. Because of these issues, we don't have any method to smoothly develop such thing. That's why we have started this project. Like making it smaller, how small it is, I can show you. This is the USB connector, and you will know how small it is. This is like one chip operation. And the device on the right hand side is the Bluetooth mobile. And the chip is inside this, and it's smaller than 1 yen coin. So we are now developing something very small like this. And the conventional mruby was used in the bigger systems, but however, now we need to make it very small and has to be operated with the smaller power. This is the object of our project. These are the specs of mruby. This has been already widely used, made by Nordic. VLE, the standard device. So what did mruby-C did? So it has the compatibility with BM. However, this uses the smaller memory than 64, maybe 60 or 30 right now. and this will operate multiple system. The OS is not incorporated. However, this can run the multiple program at the same time, which will be normally compensated by OS. However, instead of OS, we have to have some system that's and single core, and object deployment is now simplified. The class or those are simplified. However, we try to make the compatibility with mruby as much as possible. And exception was simplified, and also other system was making it very light. And the feature, because they don't have OS, this has different with the mruby or Ruby. Ruby has support from OS. However, mruby cannot get such support from OS. So it has to be operate. It has to operate the multiple program without OS, and memory maintenance will be done by OS normally. But in case of mruby, this has to be done by themselves. These are many issues that mruby have. However, the total size will be very smaller. The Ruby will be operated in PC or like server application, and mruby will be operated by the maybe Raspberry or larger size of the equipment, maybe 400 KB. And mruby-C is even smaller, which can be operated by one-chip micron. One-chip micron has a lot of advantage, such as cheap, and also saving energy. This uses very small energy, and also the security can be secured. This is incorporated in one chip, and it's very hard to retrieve the data from inside. So security is there, maintained. So this is quite suitable for IoT. So now I'm going to switch over to Higashi-san. However, just to give you one concrete example, this is sense stick that we are considering. The weight is only 5 grams. So now mruby is incorporated, mruby-C is incorporated in such a small wearable device. And sensing and the data will be transmitted by Bluetooth, and which can be monitored. So Higashi-san will later talk about that mruby is already disclosing this in GitHub. And I hope you can enjoy and experience. Now I want to turn over to Mr. Higashi.
Okay, so sorry for that. I would like to continue. So I'm Hirohito Higashi. I'm a researcher at the Shimane IT Open Innovation Center. Just to briefly, I'd like to introduce myself. So my name is Hirohito Higashi. So in the past, the embedded system applications, I was involved in the development of Alone. And that was that won the improved version of the Alone in Fukuoka Ruby Award. And we have done the presentation about it in the past Ruby conference. So this is the agenda for today. So why do we use mruby-C for embedment, and the area in which the applicability is high, and also how to use the mruby-C. So Tanaka-san has talked about many technical things, so I would like to be kind of an entertaining portion of this presentation. So let's just look back on the past. So in the past, embedded program used to be created only by assembler. That was the only option. So the register model or memory model were manipulated by people, which is provided by Micron, and it was inefficient in development because assembler, there is no structure for control, so we had to do it in a spaghetti way. But register model So computation results have to go to the accumulator, or C register should be used as a counter, and R31 register can only see 0 and all that. So currently, because it's not sustainable, so C programming language has become possible, and which improved the development efficiency, and register model has been hidden, and memory model remained as pointer. So in a C language, person who writes the program has to look at this the usage. So when we look at the future on the right, so maybe now it's already the future, but we use the high-level language for the programming, and to deal with this programming. So mruby and mruby/C should be promoted, because these are object-oriented languages, so which would enable the object-oriented programming, and which will further improve the development efficiency, and the memory model can be hidden. And this is a programmer-friendly environment that we can establish. This is the future stage that we would like to achieve. In terms of the C layer, on top of the C layer, it was supposed to be that the C++ will come. Maybe some people might wonder about this, because I was one of them. But what about C++? I often use C++, so I do not try to disrespect this, but in C or C++ languages, there are many traps. So the things that you can do but you should not do. So if you write in C language, please raise your hand. Many people use Ruby, I guess. So less than half. It's alright. So the program on the left and right, the code can be properly compiled, and if you run this, it seems that it's okay, but actually this code should not be done. So I hope I don't have much time to explain later, so if you're interested, please take a look at this later. So this is not actually very friendly to people, and also the educational costs. So C language, this white book, people who use C language said it's a Bible that everyone should carry. And about a year ago, when I asked, do you have it? And only 50% had this book. And I felt that I'm getting old. But for C language, there's just one book. And if you go to a more advanced, maybe you need 3 books. But when you go to C++, this book is larger, and it's thicker. It's maybe 2 times thicker. So you can see it's more content. So this is the book written by the developer of the C language. And if you would like to learn more advanced C language, you have to learn all these books. And in C++, there is a template. So personally, this STL template, unless you are very familiar with this STL, I think the benefit, you can only get the 50% benefit of using C++. So cute container or other things, but if you cannot use the template, it's not really beneficial to use C++. And in order to master the templates, you have to learn all this. So my point is that there is a very high educational cost. So this kind of a language is difficult, and it's not really fun to use this kind of language. And as I said, I often use C++, so I not like I don't like the C++, but it's like we have to tame this kind of a difficult and tough C language, and it gives me kind of a pleasure. And if certain people feel that it's a very strange personality I have, but it's very complicated. But in order to deal with this complicated programming, the tools like object-oriented programming should be used to improve the development efficiency. And the tools, C++ has a too high educational cost. So the question is, why Ruby? The answer is that because I like Ruby. I was expecting an applaud from everyone. Thank you for that. So with Ruby, the issues that I have laid out so far can be solved pretty nicely. And we do not expect to replace all the embedded programs. But if there are some regions to be replaced, I think more than 80% can be covered. And around less than 20% should be done by assembler. So I think we should make our lives easier by using the high-level language. So the second topic, actually I'm running out of time. So in terms of the area or field in which the applicability is high, so it's a sensor device, IoT. So there's a need to use the smaller size microcomputer, and the repetitive verification is needed. And if the sensor node has to handle some processing, so if there is no processing required, other language can handle. But if the particular pattern has to be judged, in that case, the high-level language has to play a part. And next case is the product customization. So this can be applied to users who already have a particular product. So the base is covered by C language, and if you want to do something on top of that, the customized portion can be done by mruby or mruby/C. So depending on the where you apply it, there are some parameters. So default is 10, but if this place at this part, it should be 12. So, but it's not really flexible. So then it's also possible to change the performance depending on the script. And the third point is the complicated processing. So if the several sensors or several actuators are involved, the processing can be pretty complex. So in order to handle those complexity, we need to use the complex tool. So state chart or decision table, it can be used. But in order to run those programming, we need to use the language which can express those things in a simple way. So there is a PLC which is often used at factories. So this language has been used for such a long time, but it's not really capable. It's not capable of handling the complexity that are required today. So for that, if we use Ruby, then it is possible to handle the what is required. So the last one, how to use it. So the source code, it is BSD license. It's published on GitHub. So please search on RWC. And version 1.1 RC1 has been released on 24th of October. So I hope that you would give us your feedback. And the actual example, so let me talk about two examples. So one is, currently we are also working on the IBE for mruby. And this will be completed soon. And once it is complete, we will put it on the internet. So you can run IDE on PC, and corresponding firmware should be written on the target microcomputer, and then it can be written to the target. So this is for the beginners. I think this is a better way for the beginners to use. And the second way to use it, it's mixed with a C language. So as Tanaka-san explained, with the mruby compiler, there is an intermediary code generated, and then you combine that with the existing C language program and also the VM C language code. So all these three will be combined and written onto the target. In summary, so for the embedded systems, we need the power of the high-level language. So if there is a complexity, we should deal with the language that are capable of handling those complexity. And there is a larger programming paradigm than C language. So if it is a closed C language world, you would not have a view of other wider world, a wider paradigm. So if you write only with C language, that insights can be useful. So getting to know the larger paradigm is very useful. In order to do that, mruby or mruby slash is a very good tool, and it can be a very good friend to you. And lastly, I would like to conclude my speech with the word happy hacking. Thank you for your attention.
Thank you very much. If you have questions from the participants, would you please raise your hand? Now I'm going to bring you the microphone. Please wait for a moment. I have two questions. One is the version 1.1 will be soon, but in maybe half a year later or 1 year later, what kind of class will be achieved? Do you have any roadmap news that you can share with us? And second is IDE. You talked about IDE. You showed a photo, like one chip micron, like pin assignment, and also IDE plugin with the mruby that will make development very smooth. If you have any timeline or dream or like hope you have, would you please share with us? The first one is about one chip micron. For pin assignment is still fixed, and it's dependent on the firmware. The firmware is incorporated on the micron board. And if we need to change this, we have to change this firmware, which is very difficult. Of course, we will share the information. If this can be achieved, we can make this flexible. However, currently, still the pin assignment is fixed. But for the reading from Ruby, like digital I/O can be used. However, still, it will be fixed per device. And the other one, for the roadmap, so far, it's like basic class. Only basic class is supported. I'm going to increase, of course. However, I'm going to put many things as optional, like string or float optional. So we are going to like maintain most of them as optional, which is very similar to GEM. And the class which is important, such as the exclusion, this will be necessary. And we are going to work hard to expedite this development and concurrent executions, the communication between the concurrently operated programs. Of course, we are going to provide those later on. Thank you for your question.
Thank you. Any other questions? If not, we would like to end the earlier presentation. So, Mr. Tanaka, Mr. Higashi, please give them a big round of applause. Thank you.